Okay, today I'm going to solve two problems with indeterminate form, and I think on this I will close the topic of limit, at least for now. So we have limit square root n squared minus 2 minus square root n times n minus 2 n approaches to infinity. So we have indeterminate form of type infinity minus infinity. Okay, so our task is to try to turn this indeterminate form into indeterminate form that can be where we can apply L'Hopital rule, which means we need to try to convert in either 0 to 0, or infinity to infinity. Okay, let's see which one is going to work. So first of all, I want to get rationalize and get rid of square root. To get rid of square root, I have to, since I have here, let's say, this first square root a, this second square root is b, and I have a minus b. So I'm going to multiply a minus b by a plus b to fill out formula a squared minus b squared. Let's do that. Limit n approaches to infinity. We have square root n squared minus 2 minus n times n minus 2 and multiply by n squared minus 2 plus n times n minus 2. Okay. In denominator, we will have to divide to this expression that we multiplied, numerator. So it's going to be n squared minus 2 plus n times n minus 2. Okay? So what's going to be next? I'm going to apply formula a squared minus b squared, which is going to be limit n approaches to infinity, and we have n squared of this one minus squared of this one. Yes? Okay, it's going to be practically n squared minus 2, let me go step by step, square of this one, and put square on this one, right, like that, and minus square root n times n minus 2 and square of this one, and divided by n squared minus 2 plus n times n minus 2. Okay, so from here we are getting square of n squared minus 2. It's going to be n squared minus 2, right? Minus, it's going to be n times n minus 2. Yes? Divided by the same thing. Square root n squared minus 2 plus n times n minus 2. Okay, this is equal limit n approaches to infinity, and we are getting n squared minus 2 minus n squared plus 2n. Where right away I can cancel this. And in denominator, it's gonna be the same thing for now. N squared minus 2 plus square root n times n minus 2. And that is equal limit n approaches to infinity. We are going to have 2n minus 2, right? Let me take the n out. Okay, let me rewrite clean so it won't be a problem. Now in denominator, since I'm going to do the same thing to numerator, so let me start with from denominator. I'm going to, because in denominator I have infinity plus infinity, so I'm going to do changes, so get rid of infinity in denominator, which is gonna be, I'm going to take n squared out, and I will have 1 minus 2 divided by n squared, yes? Plus, also I am taking, so here I will get n squared minus 2n, right? Under square root. So I'm taking n squared out, and I will have 1 minus 2 over n. All right, so is equal limit x approaches to infinity. Let's see, from numerator I'm taking n out, because the way I have, it's going to be also infinity. So it's going to be 2 minus 2 over n. Because n is infinity, I'm trying to divide by n, so infinity convert into 0. And here, if I take n squared here, and take n squared here, it's going to be n, right? N will be here, square root, and without, it will be 1 minus, let me clean this, it's going to be 1 minus 2 over n squared, and plus n will come out here also, and we will get 1 minus 2 over n, right? Now this n is a common factor I'm taking out. So I'm taking out this n, and I have, let me see, and I have 1 minus 2 over n squared, and plus 1 minus 2 over n. This is equal. This n and n is gone, right? And as a result, we are getting limit x approaches to infinity. Actually, I might as well, let me plug it already. We can plug it. It's gonna be 2 minus 2 over infinity. And here I have 1 minus 2 over infinity. Yes? Even infinity squared is still going to be infinity, plus square root 1 minus 2 over infinity. Okay. So from here we have, this is going to be 0 because 2 divided by infinity is 0. This is also 0. This is also 0. And as a result, we get 2 over 1 plus 1. And answer is going to be 1. All right? So we could bring to via changes, we could solve this problem. All right, next one. Limit x approaches to 0. we have cotangent x 1 minus cosine squared 3x divided by x squared plus 5x. So cotangent 0 is cosine 0 over sine 0, right? Cosine 0 is 1, sine 0 is 0. So it's going to be practically infinity. So we are getting here infinity. No, so here it's going to be cosine squared 3x is going to be 1. So 1 minus 1 it's going to be 0, and in denominator is going to be also 0. So this is the indeterminate form we are going to get here, and we are going to do some changes to be able to solve this expression, to take the limit of this expression. Okay, let's see what we are going to do here. So first of all, I'm going to open up cotangent and write down as a cosine over sine. Cosine x over sine x. This way I'll get rid of cosine, right? It's multiplication, so cosine x, cosine 0 is 1. So, and here will be 1 minus cosine squared 3x. In denominator we have x squared, plus 5x, and this is going to be equal limit x approaches to 0. So this is going to be 1 because cotangent of 0 is 1, so it will be gone. We are going to have under the limit, we are going to have 1 minus cosine squared 3x and sine x times x squared plus 5x. So if we look, we are going to get, we brought it to indeterminate uncertainty 0 over 0. So limit x approaches to 0. We have 1 minus cosine squared, it's sine squared, yes? Because we have sine square x plus cosine square x is equal 1, yes? Okay, so sine squared 3x and divided by sine x. And let's take this x out of parentheses. Gonna get x plus 5. Okay, if I plug 0 into this x, I'm getting 0 here, right? Okay, I got rid of that x. So I have limit x approaches to 0, and I'm getting, this, we have this, okay, let me write down sine squared 3x, and here I have sine x times x times 5. This 5 I'm taking out. It's going to be 1 over 5 limit sine squared 3x divided by sine x times x, and this is equal 1 over 5 limit, so sine squared, I'm breaking down sine 3x times sine 3x divided by, oh, here I forgot, x approaches to 0, okay? So we have sine x here. Now I want to bring to the format sine x over x, because we know the limit of it, it's going to be 0, going to be 1, right? So I have sine 3x, so, and in denominator I have times x. So what I'm going to do, I need 3x, so here 3, multiply also by 3, right? Not to disbalance. Here I have 3x, so I need entire 3x here, and then times here also 3x. And what do we get here? Sine 3x over 3x. This is going to be equal 1 as x approaches to 0. And then sine 3x divided by this 3x is going to be another 1. All right? And we are getting, let me see, 1/5. Oh yeah, here is more. Hold on. Sine x here. And I have this x here also. So that will be another 1. Let's see what left there. 1/5 limit x approaches to 0 and we are getting 3 times 3, and in denominator what do we have? In denominator we don't have anything else. Okay, let me put 1 there instead of cleaning fractional line. And result is 9/5. And I am done. Okie dokie. Thanks for watching.